Hello guys, you're welcome back to session 2 of part 2 of our discussion on calculus differentiation. In this video, we are continuing with the rules of differentiation, and you're going to look at differentiation of logarithm functions and other rules as we proceed along. So if you are new on this channel, make sure to like this video and subscribe to the channel so that you can get more mathematics videos to help you to excel in your mathematics examination. So let's move straight away to our rules. So this one of the rules, differentiation of a logarithm function. So let's see how we differentiate a logarithm function so that we continue with others. So if I have y is equal to, or let's say y is equal to, by convention we write log as what? Ln, right? Log as Sn of a function, let's say f of x. How do you differentiate this function? By convention, you can write logarithm as a full as what? Ln. So let me write it all here. Y is equal to Ln bracket f of x. How do you differentiate the logarithm of a function? We are saying to differentiate the logarithm of a function, you also follow the same rule. It's simple. All that you need to do is differentiate the y. It becomes what? Because I'm differentiating with respect to what? X. So it becomes what? The y over the x. Okay, I'm done with that. Now I'll come to the x part. All I need to do is differentiate what? The function here, which is a f of x. So here is going to be, for the first time, going to be f prime of what? F prime of x. F prime, sorry, is going to be f prime of x. Okay, so after find the f prime of x, I'll differentiating the f of x. Now divide by the same function that was given in the question as what? F of x. And at the same time you divide, the logarithm function or the logarithm symbol is what? Removed, and that is going to be your dy over dx for a logarithm function. So let's take an example. I think with example you get it much more better. So let's take an example. Let's say an example 1. Example 1. If y is equal to log of bracket 3x squared plus, let's say, 5x plus, let's say, 2, and we are asked to differentiate, what is going to be the differential for this? In this case, I have my solution. So I can say that y is equal to what? Log into bracket 3x squared plus 5x plus what? 2. This is my function. Okay, so we said that here you differentiate the function. So here it's more like an addition. Let's assume that the log is not there, so we are differentiating just function, just an addition, differentiation of an addition. So here you're going to differentiate them individually. They're going to be dy over dx is going to be, so here I'm differentiating them individually. Okay, so here when I differentiate, going to become what? 6x, because the 2 going to multiply the 3, and I'll subtract 1 from the 2, you get what? 6x. I hope that's clear. Plus, and the same thing. So here I have here to be what? 1. Okay, so 1 will multiply by the 5, so it's going to be 5, and I'll subtract 1 from the exponent here. It's going to be 0. So it's going to be x to the power of what? 0. That is clear. Plus, so when I differentiate the constant, you said differentiate the constant, you're going to get what? 0. So straight away 0. So therefore I can say that my dy over dx is going to be 6x plus what? 5. Okay, but then the log approach then is after getting or finding the derivative of the function, you divide by the original function that was given in the question. So it's going to be what? Divided by 3x squared plus 5x plus what? 2, and that's going to be your end result for log of y is equal to log of bracket 3x squared plus 5x plus 2. So let's try this one out. Let's try this one. If I have, or let's say if y is equal to 2x squared plus 3. So we log of ln, log of 2x squared plus 3. How are you going to differentiate this one too? So here, you tell us that y is equal to what? ln to bracket 2x squared plus what? 3. Is that okay? So here is going to be your dy over dx. Here is going to be differentiate them individually. So here is going to be what? 4x. Now different the constant, I'm going to get what? 0 plus what? 0. And I'll divide by the original function given the quotient, which is going to be what? 2x squared plus what? 3. So therefore I can say that my dy over dx is going to be 4x all over 2x squared plus what? 3. And that's going to be my dy over dx in this case. So let's take note of that. So try this one for me. I want you to comment your answer in the comment section and let me see. So I have y to be equal to the log of 3a cubed plus 3a cubed plus 4a squared plus 5. What is going to be your response in this? So just give you a minute, solve it and let's see. Just a minute, solve it and let's see. Or even a minute is too more, right? So let me reduce it to 30 seconds. All right, so let me solve it together so you know why you perform, why you did. Let's see whether you able to add it right or not. Whether you would add it right or not. So let's see. So here it becomes what? My dy over dx is going to be, I know here, sorry, it is dy over what? dA and not x. We are differentiating with respect to what? A. So it becomes dA. Take note. So here is going to be 9a squared plus 8a. Differential of a constant is what? 0. So once you know you've gotten the formula, you've gotten the base rule for differentiating, you can write them straight away. Okay, divided by 3a cubed plus 4a squared plus what? 5. So therefore I can say that my dy over a is going to be 9a squared plus 8a all over 3a cubed plus 4a squared plus what? 5. So you can actually factor out the numerator and you can still get it. Also, let's take note. So that is a differentiation of a logarithm function. So let's move on to talk about differentiation of products of two functions. So let's continue with the differentiation, rules of differentiation. So you are looking at differentiation of products of two functions. So now, if I have u dot v as both function of x, okay, and x is also a function of what? Y, then what is the product of two functions and the differentiation rule is saying? What is the product rule? What is the product rule saying? Okay, now this is what you're going to do. Always the product rule of two functions will result in addition. Take note that always the product rule of two functions will result in addition. So let's see. I know u dot v is a product of what? So it's a function of x. Is a function of what? X. Is a function of x. Okay, it's a function of x. Let me write it all. It's a function of x. U dot v is a function of x. So we are saying that product of two functions result in what? Addition. So this is how it's undertaken. First thing that you need to do is when you are differentiating product of two functions, first of all, hold the first function and you differentiate the second what? Function. After that, you tell us that that results in addition, then you come and hold the second function and differentiate the first. So this is what you're going to do. I'll first of all hold the u, so it becomes what? U. Now differentiate the v, and what are we differentiating with respect to? We are differentiating with respect to what? X. So it's going to be u differentiating v with respect to what? X. I hope that is clear. So first of all, I hold the u, now differentiate the v plus. Then after that, I'll then hold the v and I'll differentiate what? The u. So it's going to be v, and I'm differentiating the u with respect to what? X. So it's going to be what? The u dx, and that's going to give me what? My function of the x after differential. I believe that is clear. But we also know that x is also a function of what? Y. X is also a function of what? Y. So therefore, we can conclude that by saying that if I also want to differentiate y, which is equal to x, I can say that my dy over the x is going to be, and I know the differential of x, this s was what? U dv over the s plus v du over what? ds. So therefore, I can say that my dy over dx is equal to my u dv over dx plus dx. So that is the rule when it comes to differentiation of what? Product of two functions. That is the rule. We call it the product what? Rule. We call it the product rule. So the first thing you need to do is that you first of all hold the first function. Let's say the u, hold the u, and then you differentiate the v with respect to the quantity you are actually differentiating with. Okay. Then you have, we said that product of two functions result in addition. So after that, you bring your addition sign or your addition sign, and then you hold the second what function, you differentiate what? The first function, and then that is all in that case. So let's take an example so that we'll appreciate it much more better in that case. So now we have an example here, example 1, under product rule. If y is equal to, let's say x squared plus 1, then also have another function, let's say x plus 3. I am asked to differentiate this function. Let's go by the product rule. Actually, you can make a representation by saying that your y should be equal to your u and v, so that you can represent these functions as u and what? V. But then I want you to expose you to the general rule as we defined here. Okay, so here, this is what you're going to do. You have your y to be equal to x squared plus 1 as one function, multiply another function s plus 3. So this is what you're going to do. Your dy over dx is going to be, so you first of all hold this function, okay, this function, and you differentiate what? S plus 3. And here you're going to differentiate them individually. So you differentiate the x and differentiate the constant. I believe that is clear. So I'll hold x squared plus 1, and that is going to be within here. And I'm going to differentiate what? X plus 3. So when I differentiate this, I'm going to get what? Remember, the coefficient here is what? 1. So 1 going to multiply 1 here. I'm going to get 1. And I'll subtract 1 from here. I'm going to get what? 0. X to the power of 0. A number to the power of 0 is what? 1. So it's going to be 1. When I differentiate the constant, I'm going to get what? 0. So you're going to plus what? 0. So a number plus 0 is into that number. So I'm going to have this as x squared plus 1, or bracket close, multiplied by what? 1. Then I'll have my addition sign, because we said the product of two differential results in addition. Then after that, I'll come and hold this. I'll come and hold the second function, and I'll differentiate the first one. So it's going to be plus, I'm going to have here to be x plus 3, and I'll differentiate this first function, and here to also differentiate them individually. So when I differentiate x squared, it's going to give me what? 2x. Remember, all I'm doing is going to be multiplication, right? Good. And then When I differentiate the constant, I'm going to get what? 0. So it's actually what? 0. So I'm going to tell us that here. Let me do this so that you appreciate it better. Plus what? Plus 0. Likewise, here we have said that plus what? 0 here. I hope that's clear. So it should have been bracket 1 plus 0. That's what have been, that's multiplying this. So in this case, it's going to be 1 plus 0 is as 1. So it's going to be 1 multiplied by the whole expression is going to be the same expression. So it's going to be s squared plus 1 plus, then here too I have what? 2s plus 0 going to be what? 2x. So I will expand the 2s with respect to s plus what? 3. So it's going to be what? 2s squared plus what? Plus 6x. Then I will group like terms. So here I have 2s squared, I have s squared here. So it's going to be what? 3s squared, okay, plus I have it to be 6s plus what? 1. So this is going to be the differential for these two products. For these two functions, sorry, s squared plus 1 and bracket s plus what? 3. Going to be 3s squared plus 6s plus 1. Or let's go by the formula approach and let's see what you're going to get. The formula approach. So the formula approach is saying that here, all that I need to do is to represent, let me have it down here. Let's say y is equal to s plus 1, s squared plus 1, s plus 3. So the formula approach is saying that all I need to do is to represent the y to be equal to what? U and what? V. So therefore I can say that u is equal to what? S squared plus 1 and v is equal to what? S plus 3. So once I'm able to get that, I'll differentiate all the expressions one by one. So I can say that here my du dx is going to give me 2x. That is all. Constant is going to give you 0. Then here to my dv over my dx is going to give me what? 1. Okay. So therefore we said the product we're saying that therefore if I have my dy over dx is going to be my u multiplied by my dv over dx plus my v multiplied by my du over what? Dx. So all I will do here is do substitution. I know u to be what? S squared plus 1. So it becomes what? S squared plus 1 multiplied by my dv over dx, which is what? 1 plus. I know my v is what? I know my v is x plus 3. That one's also multiplying what? My du over dx, which is what? 2x. So after when you expand, it's going to be s squared plus 1 plus 2s squared plus what? 6x. I know they're going to get 3s squared plus 6x plus what? 1 plus 1. And that's going to give you my dy over dx. I think that's the same thing as what we had here. They are the same. That is the formula approach. Let's take note of. So that is going to be my answer in this case. When I use the formula and I use the normal differentiation rule, they are going to be the same. So actually, once you understand the rules better, irrespective of the formula, you can still use the rules and you're going to get it right. So let's take note of that. All right. So let's move on to other rules. But not this. At times, as we have discussed with other rules, they might combine some of the rules. Like you might get, let's say, a function involving logarithm and another function. The same rule applies, and you also must take note of the rule of what? Logarithm. When it comes to differentiation of the rule of logarithm, if let's say you have a logarithm function and another function, you must make sure that once you are differentiating logarithm function, you divide by what? The same function, and you also differentiate the other function, but then the product is going to what? Apply. So let's take note of that. All right. So let's move on. So we'll solve more questions as we move along. solve more questions. So let's move on to the next rule that we're going to deal with. So the next rule we're going to talk about is the quotient rule. The quotient rule, also call it the division rule for differentiation. So let's see. So let's continue with the quotient rule. Quotient rule. So the quotient rule also works the same as that of the product, but just that the quotient rule, it deals more like the division and it will result in what? Subtraction. Quotient rule deal with division, but we're going to result in what? Subtraction. After differentiation, going to result in subtraction. So let's see. So if I have u over v, which is a function of, which both are the function of what? X, and x is also a function of what? Y, then how does the quotient rule applies in when it comes to differentiation? So let's see how the quotient rule works. So here, this is what I will do. If I know that here I have u to be over, v is equal to x, this is what I will do. Let me write it here so that you can expand them. As I have, or let me write in this way, I have x to be equal to u over v. So this is a function of what? X, but we are saying that x is also a function of what? Y. All right, so let's see how we'll differentiate this. We are differentiating with respect to what? X. So let's see. So what I will do here is say that x is equal to, I will write this in an exponential form. I mean the v here, the denominator. So I can say that here u dot multiplying v to the power of -1. I hope that is clear, because I can write this. The inverse form of 1 over v is the same thing as v to the power of -1. -1 is what? 1 over v. So that's how I had it with -1. So let's take note of that. So I want to write them in a more like a row form, all right, so that the inverse form of 1 over v will come and multiply the u. I'm going to have it in this form. I believe that is clear, right? So now let's start with the row differentiation for this. So here it results like a product having u dot what? V, right? But here so we're having -1 here, so we're going to use the same product rule to differentiate in that case. So let's see. So what I will do is first of all hold what? The u. Okay, so I'll hold the u and I'll differentiate the v. So if I hold the u, I want to differentiate the v, rules of differentiation still what? Apply. So first of all, I'll multiply what? The -1 by the coefficients of what? The 1 here. So it's going to be into brackets multiplied by the coefficient of what? The u, and even here is also what? 1. So it's in terms the u. So I'll multiply here by what? -1. All right, and then I will differentiate the actual v, assuming the -1 wasn't there, with respect to what? X. So it becomes what? dv over what? dx. Okay, and remember that once you differentiate, you need to subtract 1 from the exponent, which goes to what? Which is the -1 here. So it's going to be into bracket v, which is going to be -1, -1. All right, so that is the whole for, or the whole differentiation for where you hold the u and differentiate what? The v with respect to having an exponent of -1. So once you are done, you bring your addition, because we said product of two functions results in what? Addition. And you also do same for the u. So in this case, you're going to hold what? The -1 here, -v exponent v to the power of -1, and you differentiate what? The u. Because the u don't have any -1, straight away it becomes 0. You multiply the 1 by the u and subtract 1, you're going to get what? 0. So when you differentiate, it becomes what? Du over what? Dx. So it becomes into bracket du over what? Dx. And if you like subtract 1 from the exponent of 1 here, you can get 0. Any number to the power of 0 is 1. So you're going to get what? Du over what? Dx, multiplying v to the power of -1. So I first of all hold the u and I differentiate the v, and I bring my addition sign and I hold the second function, I differentiate what? The u, and that resulted in this. So let's expand it further. So I can say that x is equal to, so let's say you're going to be -u, your dv over what? Your dx, into bracket your v to the power of -2. Is that okay? plus, I know here is going to give me v of -1 into bracket my du by my dx. I believe that is okay at this point. All right, let's continue. So let's simplify it further. So I can say that x is equal to, you can say x is equal to here, I can say that x is equal to my negative u dv over dx all over v square. Remember, here is -2, so I'll find the inverse of what? V to the power of -2 is going to be what? 1 over what? 1 over v squared. So let's take note of that. Let me erase it. So that's why we have here to go v squared plus. So here's the same thing, becomes for your du over dx out of what? V. I hope that is clear, right? So once you're able to get to this stage, let's simplify further that you write in this form. So I can say that x is equal to so let me rewrite further. X is equal to my du over dx all over v minus minus u, so minus u my dv over dx all over what? V squared. Hope that is clear, right? So once you get to this stage, we can say that x is equal to, let's simplify further. We can say that here the LCM is what? You can say the LCM is v squared, right? The LCM is v squared. The LCM is v squared. So here is going to be so if LCM is v squared, then you can say that v goes to v squared how many times as what? V. So the v is going to multiply the du over ds. So going to be v multiplying my du over what? My dx. I have my minus sign, and I know v squared go to v squared times 1 multiplying by the whole expression here going to be what? The same u multiplying dv over dx, and therefore I can say that x is equal to v du dx minus u dv dx all over what? V squared. So once I'm able to get this, that is for the differential for the x. But we said that x is also a function of what? We said x is also, but we said that x is also a function of what? Y. So that is x equal to what? Y. So this is what we're going to do. So we also said that x is also a function of what? Y. Okay, so here all I will do is to differentiate what? Y. So I'm differentiating y with respect to what? S. So I can say that y is equal to what? Y is equal to x. Oh, sorry. It's equal to, so I can say that my dy over dx is going to be, I know the differential of my x was as a result of what? V du dx minus my u dv over dx all over what? V squared, and hence the quotient rule, and hence my product, sorry, my quotient what? Rule. So this is how we derive the quotient rule using the normal differentiation approach. All right, so let's take an example and see how far we can go. So let's take an example 1 under the y is equal to 3x plus 2 all over x squared. So here we are asked to differentiate this. It's two functions in a division form, right, or in a ratio form. So here all I will do here, I can say that let y be equal to u over what? V. So in that case I can conclude that by saying that u is equal to what? 3x plus 2, and then v is equal to what? S squared. Hope that is clear. So here I'm going to differentiate each expression individually. So it's going to be du dx is going to be what? 3. Remember, constant is going to give you 0. Is that okay? So no need, 0. Then here is going to be my dv, going to be my dv over dx, and that's going to give me what? 2x. I believe that is clear. All right, so that is 2x. All right, so here, once you're able to go through with this, then you quote your formula that I know my dy over dx under the quotient rule is equal to v du dx minus u dv dx all over what? V square. Hope that's clear. So yeah, I can say that I know my v is what? S squared into bracket. I know du over dx is what? 3. Now I have my subtraction symbol or sign. I know my u to be what? 3x plus what? 2. Then I know my dv over dx to be 2x. And I know my v to be what? V is what? S squared. So it's going to be what? S squared all squared again. All squared again. Alright. So here is going to be 3x squared minus. So let's expand this one too. Let's expand the 2x and with the expression 3x plus 2. So it's going to be 6x squared. Alright, remember the bracket is still there, plus your 4x in this case. Is that okay? So after this, you divide by, I know here you're going to multiply the 2 by the 2 here. So it's going to be what? X to the power of what? 4. So then it is going to be 3x squared minus 6x square minus 4x. I believe that is okay, right? All divided by what? X to the power of 4. So you keep on repeating your dy over dx, your dy over dx, your dy over dx. So therefore I can say that dy over dx is going to be, I know 3x squared, I know it to go negative 6x squared. So it's going to give me negative what? 3x squared minus 4x all over x to the power of what? 4. So therefore I can do some factorization out. Okay, so I can say that my dy over dx is going to give me negative x into bracket 3x plus what? 4 all over x to the power of what? 4. Yeah, I can apply my indices and still get some of them clear, but because of the sign, the negative sign here, come a bit to reduce, so you can leave your answer in this form, and that is going to be okay. Or better, you can still reduce it if you want to. Based on the final answer, that will determine whether your final answers also meet their criteria in that case, based on the exam you are writing. So that is the quotient rule and its application. So let's take note of that. So all other rules that we have discussed can apply. They can give you logarithm, they can give you an exponential, let's say they can give you a logarithm as a numerator, and then let's say an exponential as denominator. Remember that you're going to apply the quotient rule, but then the other individual rules like logarithm rule of differentiation and exponential will still apply. So you don't take them for granted. You must take cognizance of these rules too when you are applying them in the cosine rule, or sorry, in the quotient rule or the product rule. Hope that is clear. So that's something that we need to know. So this is where we bring an end to the section 2 or part 2 of our journey on calculus and differentiation. So if it was helpful to you, please make sure to like this video. If you haven't subscribed, make sure to subscribe so that you can get more videos on this to assist you and to pass your examination, and any examination or math activity that you may engage on. So I'll see you in the next video where we discuss the part 3, where we engage in the chain rule, the higher derivative, and then the implicit differentiation and we move on to even the application of differentiation. So I'll see you. Bye bye for now.